Okay, so our next section is about finding confidence intervals for unknown population means mu by using x bar, the sample mean. But now we're going to be in the situation where we don't know the population standard deviation sigma. And that's, I guess, the more common situation than actually knowing it, since we don't even know the mean of the population. So when we don't know sigma, we have to approximate it with the standard deviation of the sample. We call that S, the sample standard deviation. And when we make that approximation, we're introducing more variability into the situation. And so that causes us to actually not be able to use a normal distribution for finding confidence intervals. Instead, we have to use what are called t-distributions. And there's a different one for every sample size. The language we use to describe the t-distribution that we want is the one that has n-1 degrees of freedom, where n is the sample size that we're taking. So the language takes a little getting used to, but what the degrees of freedom refers to is that when you're using an x bar, so if you know x bar and you know n-1 of your data points, then you can actually figure out algebraically what the nth or last data point has to be. So if you know x bar, only n-1 of the data points can vary freely because the last one is determined by those n-1 and x bar. So we say that we have n-1 degrees of freedom because we have n-1 data points that can vary freely. Now, it's not particularly important that we remember where the language comes from necessarily at this stage. What is important is to recognize that the degrees of freedom is just n-1. So whatever your sample size is, subtract 1, and that's the degrees of freedom that you'll have to plug into the StatCrunch calculator when you're doing t-distribution calculations. So we'll do an example or two of that in just a moment. I did want to call your attention to an applet on StatCrunch that I think is useful. And this is under Distribution Demos. And I'm going to do t-distribution demo. And this just shows kind of what the t-distribution looks like for a variety of degrees of freedom. So if I click Show the Standard Normal Distribution, and I start with the smallest possible degrees of freedom, that's 1. The black distribution, the shorter one, is the t-distribution with 1 degree of freedom. And so notice that the tails are fatter. That means we have more probability for more extreme results. Now, as we increase the degrees of freedom, so I'm just going to slide it over, you can see that the black distribution gets closer and closer to the standard normal distribution. As we increase the sample size, what's happening is the distribution is becoming more and more like the standard normal distribution to the point where this goes up to 35. It's really hard to visually distinguish the two. So t-distributions, right, there's one for every sample size, and they're still symmetric, bell-shaped, but they have fatter tails than the standard normal. All right, so I'm going to do the calculations required for our two examples from the notes. So I need to go to Stat, Calculators, and now down to the t-distribution. And just like the standard normal, you can select a left area or a between area. So I'm going to do a between area. And in the first example, we wanted the 95% confidence interval, and our sample size was 100. So my degrees of freedom is 99. And I'm looking for the cutoff that gives me the middle 95% of the t-distribution with 99 degrees of freedom. So my middle area is a 0.95. And when I compute that, I get a minus 1.98 to 1.98. Notice that's really close to the standard normal, which would be minus 1.96 to 1.96, and the difference is that we have a t-distribution here, and the reason they're so close is we have a pretty large sample size. So we have 99 degrees of freedom. The two distributions are very close. In example 2, we're going to need the t-score or t-value for a simple random sample of size 36. That means 35 is our degrees of freedom. And the area I'm interested in is the middle 99%. So if I compute that, I get t-scores of minus 2.72 to 2.72. All right, so in the first case, 1.98, in the second case, 2.72, and I'll use those values in the examples for the chalkboard video, and hopefully this will help get you started on the worksheet.